The Sukhoi Su-47 Berkut, also designated S-32 and S-37 during initial development, was an experimental supersonic jet fighter developed by Sukhoi Aviation Corporation. A distinguishing feature of the aircraft was its forward-swept wing that gave the aircraft excellent agility and maneuverability. While serial production of the type never materialized, the sole aircraft produced served as a technology demonstrator prototype for a number of advanced technologies later used in the 4.5 generation fighter Su-35BM and current 5th generation jet fighter prototype Sukhoi PAK FA T-50. On August 11, 2014, Commander-in-Chief of the Russian Air Forces, Colonel General Viktor Bondarev claimed that Russia is still continuing the research and development of Su-47 or similar forward-swept wing fighters. The new prototypes of such aircrafts will be unveiled in the near future. Development: originally known as the S-37, Sukhoi redesignated its advanced test aircraft as the Su-47 in 2002. Officially nicknamed Berkut, the Su-47 was originally built as Russia's principal test bed for composite materials and sophisticated fly-by-wire control systems. TSAGI has long been aware of the advantages of forward-swept wings, with research including the development of the type in LL and study of the captured Junkers Ju-287 in the 1940s. Forward-swept wings yield a higher maximum lift coefficient, reduced bending moments, and delayed stall when compared to more traditional wing shapes. At high angles of attack, the wing tips remain unstalled, allowing the aircraft to retain aileron control. Conversely, forward sweep geometrically creates increased angle of incidence of the outer wing sections when the wing bends under load. The wings experiences higher bending moments, leading to a tendency for the wings to fail structurally at lower speeds than for a straight or aft-swept wing. The increased bending moment is countered by designing the wings to twist downward as they bend upward. The project was launched in 1983 on order from the Soviet Air Force. But when the USSR dissolved, funding was frozen and development continued only through funding by Sukhoi. Like its U.S. counterpart, the Grumman X-29, the Su-47 was primarily a technology demonstrator for future Russian fighters. Design: the Su-47 is of similar dimensions to previous large Sukhoi fighters, such as the Su-35. To reduce development costs, the Su-47 borrowed the forward fuselage, vertical tails, and landing gear of the Su-27 family. Nonetheless, the aircraft includes reduced radar signature features, an internal weapons bay, and space set aside for an advanced radar. Though similar in overall concept to the Grumman X-29 research aircraft of the 1980s, the Su-47 is larger and far closer to an actual combat aircraft than the U.S. design. To solve the problem of wing twisting, the Su-47 makes use of composite materials carefully tailored to resist twisting while still allowing the wing to bend for improved aerodynamic behavior. Like its immediate predecessor, the Su-37, the Su-47 is of tandem triple layout, with canards ahead of wings and tail planes. Interestingly, the Su-47 has two tail booms of unequal length outboard of the exhaust nozzles. The shorter boom, on the left-hand side, houses rear-facing radar, while the longer boom houses a brake parachute. Maneuverability: the Su-47 has extremely high agility at subsonic speeds, enabling the aircraft to alter its angle of attack and its flight path very quickly while retaining maneuverability in supersonic flight. The Su-47 has a maximum speed of Mach 1.6 at high altitudes and a 9G capability. The Su-47 aircraft has very high levels of maneuverability with maintained stability and controllability at extreme angles of attack. Maximum turn rates are important in close combat and also at medium and long range, when the mission may involve engaging consecutive targets in different sectors of the airspace. The swept forward wing, compared to a swept back wing of the same area, provides a number of advantages: higher lift-to-drag ratio, better agility in dogfight situations, higher range at subsonic speed, improved stall resistance and anti-spin characteristics, improved stability at high angles of attack, a lower minimum flight speed, a shorter takeoff and landing distance. Wings: the forward-swept midwing gives the Su-47 its unconventional appearance. A substantial part of the lift generated by the forward-swept wing occurs at the inner portion of the wingspan. This inboard lift is not restricted by wingtip stall and the lift-induced wingtip vortex generation is thus reduced. The ailerons the wing's control surfaces remain effective at the highest angles of attack, and controllability of the aircraft is retained even in the event of airflow separating from the remainder of the wing's surface. A downside of such a forward-swept wing design is that it geometrically produces wing twisting as it bends under load, resulting in greater stress on the wing than for a similar straight or aft-swept wing. This requires the wing be designed to twist as it bends opposite to the geometric twisting. This is done by the use of composite wing skins laid up to twist. Despite this, the plane was initially limited to Mach 1.6. Recent engineering modifications have raised this limit, but the new limit has not been specified. Thrust vectoring. The thrust vectoring of a plus or minus 20 degree at 30 degree per second in pitch and yaw will greatly support the agility gained by other aspects of the design. Cockpit. The cockpit's design has focused on maintaining a high degree of comfort for the pilot and also on the pilot being able to control the aircraft in extremely high G-load maneuvers. The aircraft is equipped with a new ejection seat and life support system. Specifications. Data from World Aircraft and Systems Directory. General characteristics. Crew. 1. Length, 22.6 meters. Wingspan, 15.16 m to 16.7 m. Height, 6.3 m. Wing area, 61.87 mass squared. Empty weight, 16,375 kilograms. Loaded weight, 25,000 kilograms. Max takeoff weight, 35,000 kilograms. Power plant, TUA, Lyalk AL-37FU. Prototypes use two Aviad Vigotl D30F6 afterburning, thrust vectoring turbofans, dry thrust, 83.4 kN each, thrust with afterburner. 142.2 kN each. Thrust vectoring, A plus or minus 20 degree at 30 degree per second in pitch and yaw. Performance. Maximum speed, Mach 1.65, at sea level, Mach 1.16. Range, 3,300 km, service ceiling, 18,000 m, rate of climb, 233 meters per second, wing loading, 360 kg mass squared, thrust weight, 1.16/1.77, armament. The Su-47 is an unmanned technology demonstrator. If further developed into a fighter, the armament could include the following weapons: guns 1A, 30mm GSH-30-1, missiles, up to 14 hardpoints, air-to-air, R-77, R-77PD, R-73, K-74, air-to-surface, KH-29T, KH-29L, KH-59M, KH-31P, KH-31A, KAB-500. KAB-1500. See also: JXX, medium combat aircraft, Mitsubishi ATDX, related development, Sukhoi Su-27, Sukhoi Su-30, Sukhoi Su-33, Sukhoi Su-34, Sukhoi Su-35BM, Sukhoi Su-37, aircraft of comparable role, configuration and era, Grumman X-29, Micron Project 1.44, Sukhoi PAK FA/Sukhoi HAL FGFA, notes. References. External links: S-37 Berkut at fighter-planes.com, S-37 at airforce-technology.com.